Algebraic expressions. An algebraic expression is an extension of arithmetic where letters are used to represent numbers. Let's look at the features of an algebraic expression. Consider the expression 2x plus 5y plus 2. The parts separated by a plus or a minus are called terms. The expression above has 3 terms. The letters x and y are called variables. The number in front of the variable is called the coefficient of that variable. That is, 2 is the coefficient of x and 5 the coefficient of y. The last number is fixed and it is known as a constant. Whenever the coefficient is 1, it is not written. Simplification of algebraic expressions. In addition and subtraction, only like terms are added or subtracted. For example, 2x plus 4y minus x plus 3y plus 5. Simplified, it would be 2x minus x plus 4y plus 3y plus 5, giving the answer as x plus 7y plus 5. What are some of the real-life situations that would lead to formation of algebraic expressions? Let us look at an example. A man is 3 times as old as his son. The son is 12 years older than a younger daughter, who is a half as old as their mother. Give an expression to illustrate their total age. In our solution, let the age of the son be represented by x. Then it means the father is 3x years. The daughter is x minus 12, since she is 12 years younger than the son. The mother is twice as old as the daughter, and therefore her age is 2 times x minus 12 years. Their total age is x plus 3x plus 2 into x minus 12 into bracket plus x minus 12. Simplified, we get 7x minus 24 years. Multiplication and division of algebraic terms. Whenever we say 3a, we simply mean 3 times a. Thus, 2 times 3a simply means 2 times 3 times a, which is 6a. And just like 3 times 3 is 3 squared, x times x is x squared, y times y is y squared, and so on. However, x times y is xy. This cannot be simplified further. Equally, x divided by y is simply x over y. What then is 2x times 3y? This is similar to 2x times 3 times y, which is equal to 6xy. Also, 2x times 3x will be 6x squared. 6x divided by 3y is 6x over 3y, which is 2x over y. When you multiply an expression in brackets, with a number outside the same bracket, ensure that all parts of the expression have been multiplied. For example, 2 into 3x plus 4y minus 2z close the bracket means that 2 times 3x plus 2 times 4y minus 2 times 2z, which gives us 6x plus 8y minus 4z. Similarly, 2x into bracket 4y plus 2x minus 3z is the same as 2x times 4y plus 2x times 2x minus 2x times 3z. This gives us 8xy plus 4x squared minus 6xz. Factorization of algebraic expressions. We have previously seen how factors are used in mathematics and how they are evaluated. The same principle applies to algebraic expressions. Consider an expression bx plus by. In both terms of the above expression, b is common. We can therefore say that b is a factor, and hence we can have b into bracket x plus y. We say that expression 1 has been factorized into expression 2. Now look at 2x squared plus 3xy minus 4xz. X is common to all terms, and hence we can have x into bracket 2x plus 3y minus 4z. 4x can be factorized into 2 into bracket 2x. Look at all these expressions the way they are factorized. 5xy minus 15y squared plus 25y is equal to 5 into bracket x minus 3y plus 5 close the bracket. 25x squared is the same as 5x into bracket everything squared. 14x squared y minus 7xy squared plus 28x squared yz squared is equal to 7xy is common to all, therefore it is outside the bracket. Inside the bracket we have 2x minus y plus 4xz squared. Factorize the following: 8xy squared minus 4x squared y plus 16z squared yx. Algebraic fractions. These are fractions with either a numerator or a denominator which is an algebraic expression. Consider 2x minus 3b over 5 plus 2b minus 4x over 6. The terms 2x minus 3b and 2b minus 4x represent numbers and could as well have been numerals, say like 1, 2, 3 or 100, so that we could have had 2 over 5 plus 3 over 6 instead of the algebraic expressions, where 2x plus 3b is represented by 2 and 2b minus 4x represented by 3. In simple terms, we solve the equations in the same way as we did with the conventional fractions. That is, find the LCM of the denominator. For the case above, LCM of 6 and 5 is 30. We thus have 2x minus 3b over 5 plus 2b minus 4x over 6. 30 divides into 5 6 times. We therefore have 6 into 2x minus 3b plus 30 divides into 6 5 times. So we have 5 into 2b minus 4x. Simplified, we have 12x minus 18b plus 10b minus 4x. Further, we get 8x minus 8b. Factorizing that, 8 is common to the numerators, so we have 8 into x minus b over 30. 8 divided into 2, we get 4, and 30 by 2, we get 15. Our final answer is 4 into x minus b over 15. What if the denominator is an algebraic expression? Well, there is no magic absolutely, and the trick is the same. For example, 3b over 2x plus 4a over 3y. The LCM of 2x and 3y is simply 6xy. Then we proceed as usual. 6xy divides into 2x 3y times. So we have 3y into 3b plus 6xy divided by 3y, we get 2x. Multiply that by 4a. Eventually we have our answer as 9by plus 8ax over 6xy. A more complex example is as follows: 3a minus 4x over 2x squared y minus 3b plus 7x all over 5y squared x. The LCM of 2x squared y and 5y squared x is 10x squared y squared. We then proceed as 10x squared y squared divide into 2x squared y, we have 5y. Multiply that into 3a minus 4x. 10x squared y squared divide into 5y squared x, we get 2x. Multiply that by 3b plus 7x, which gives us 15ay minus 20xy plus 6bx minus 12x squared all over 10x squared y squared. Let's look at problem solving using algebraic expressions. Example 1. Two consecutive integers are such that the smaller one is u. Find the sum of 3 times the smaller number and 8 times the larger number. In our solution, consecutive integers differ by 1. Therefore, if the smaller integer is u, the larger one is u plus 1. 3 times the smaller one is 3 times u. 8 times the larger one is 8 times u plus 1. The sum is 3u plus 8 into u plus 1, and the answer is 11u plus 8.
And so you can go on and learn math. You may need tutorials, you may need tutors, etc., to get your foundation solid so that you can build the next course on it. But math is not so complicated that most people can't learn high school math and certainly the introductory courses in university. If you want to go on and major in math or do honors in math or do a career in math, you really do need to be good at it. But I think too many people stop out too soon because they've had bad experiences.